Alright, boys and girls, welcome to video lesson 10-5, our continuing saga in circles, and now we're going to talk about tangents in circles. Here we go, here we go, here we go. There are two new theorems we're going to be talking about in 10-5 here. They both have to do with tangents. To remind you what a tangent line is, a tangent line is a line that touches a circle in just one point. Okay? So the first theorem says if a line is tangent to a circle and I draw a radius to that tangent line at the point of tangency with the circle, then it is a right angle. And this theorem, like all of our other theorems so far in this chapter, works both ways. So if this line, this line that's a radius drawn to a tangent is perp, therefore it then touches at the point of tangency. Okay, so there's our first theorem. And our second theorem is just as quick and just as easy. It says if I have a point outside of my circle, and I draw a tangent to one side of my circle on one side, and I draw a tangent to the other side of the circle, these two segments must be equal. Okay? There are two types of problems we're going to be doing, or actually there's a bunch, but two ones that are a little bit tougher. The first one is called a walkabout problem. Okay? This involves a circle that's inscribed in really any polygon. We're going to be dealing with four-sided polygons, which you guys know as quadrilaterals. Okay? In this particular problem, I have a circle inscribed in this quadrilateral, this four-sided figure. And the point is when you do that, we have now created a bunch of two tangents. In other words, these two red lines are both tangent to the circle from a common point. So these two red lines are congruent. Likewise, this green tangent line with this green tangent line, these are going to be congruent. I can do some blues. This blue line is going to be congruent to this blue line. Okay, and lastly, but not leastly, let's do another color. I don't care. Let's do that orange. That's not a color. Let's do this green right here, this yucky green. This green right here is going to be congruent to that green right now. Okay? We are looking for the length of this missing side. That's what we're missing, or that's what we're looking for. Okay? So I'm going to start by just walking around this quadrilateral. I don't know any of these sides. When I don't know something in math, I'm going to call it x. I'm going to let this side, this red tangent line, be x right there, which means this is also x. Now I know that this segment plus this segment add up to 18. So this red plus this green are going to add up to 18. So this missing green line must be 18 minus x, because x plus 18 minus x is equal to 8 to 18. If this green line is 18 minus x, then this green line right here is also 18 minus x. Here comes the fun part. This blue line right here, this must be 20 minus, in parentheses, 18 minus x. Because that's going to add up to 20. Okay? So now we're going to distribute my neg. So I'm going to get 20 minus 18 plus x, which of course equals x plus 2. So this blue piece right here is x plus 2, which means this blue piece here is also x plus 2. Go back up top. If I know that this total length right here is 24, this piece here must be 24 minus x, that green piece right there, which means this green piece is also 24 minus x. Green piece, I just noticed that was funny. These two pieces right here, the green piece and the blue piece, they're going to add up to my missing side. Well, I have 24 minus x plus 2. Notice now my x's are going to cancel. I'm left with 24 plus 2, which equals 26. And there is my piece. Okay, next we're going to talk about the common tangent procedure, and I'll go over with you in class what a common tangent is. But a common tangent procedure is basically a 4-step recipe to solving problems that involve common tangents. Okay, the first step is to draw a segment joining the centers. Second, draw radii in both of the circles to the points of contact. Remember, those are going to be right angles. Then there's the hard part, through the center of the smaller circle, draw a line that's parallel to the common tangent, but intersects the radius of the larger circle. Then we're going to use the Pythagorean theorem to find what we're missing. Okay? This is a common tangent problem. Notice we have a common external tangent. I'll do that in red right here. This red line is my common external tangent, and it is 12 inches according to the information that they're given. Okay? Step one of my steps, though, is to draw the line center. So I'm going to draw a line connecting my two centers of the circles, and that's actually what I'm looking for in my circle. How far apart are the centers of the circle? Okay. Step two is to draw my radii to the points of tangency. I'll do that in this reddish color right here. So I'm going to draw from here to there. That's my first radius. Don't forget that that is a right angle. We can draw this radius right here. Don't forget that is a right angle. According to the information, this radius is 3, and this radius is 8. Now, here's the fun part. We are going to draw a line through the center of my smaller circle that is parallel to my common tangent through the radius of my larger circle. So notice that these two lines are parallel. I'm going through the center of my smaller circle all the way parallel to my common tangent to the radius of my larger circle. Okay? What I have now created, I'm going to put this in yellow so you can see it, is I have a rectangle right here. That is a rectangle because these two are both right angles, so everything is a right angle. And I have also created a right triangle. I'll do that green right here. This green thing right here, this is a right triangle. That's a right angle right there. So now let's do some math. If this side is 3, that means that this side is 3 as well. So that's 3, which means this piece right here is 5. Hey. If this line right here is 12, and the other side of the rectangle, that is also 12. Looking at my right triangle right now, I see 5, 12, ding, 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 5, 12, x must be 13. My missing side is the hypotenuse of my right triangle. It's a 5, 12, 13 right triangle. 13 is the answer. Okay, last problem. We're going to do a common internal tangent problem. Okay, notice that that green line is an internal tangent. Okay, it's going between my two circles, and it touches just at one point here and here. Okay, I'm going to go through my four steps. The first one is done for me. I need to draw the line center, so I'm going to go from the center of the first circle to the center of the second. Draw that line. I do know that this distance is 20. Okay. Next, I'm going to do step 2 and draw my radii, the points of tangency. I do know that that is a right angle. I'm going to draw the same thing right here. That is a right angle. I am now going to draw, do step 3. I'm going to draw through the center of my smaller circle, I'm going to draw a line parallel to the internal tangent. And it said to draw it through the radius of the larger circle. What I need to do is just simply extend the radius to create a right triangle, or a right angle right there. I have now created a right triangle with yellow. I'll put that in yellow so you can see it. There's my right triangle. Okay? And I also have created a rectangle, which you can see. I'll put that in bright green right here. Okay, so all my rectangle properties still apply. Okay, so I am looking for the length of the common internal tangent. I'm looking for that length right here, which is also that length right there. I also know my radii. This radius is 10. This radius is 5, which means this is also, I'm ahead of myself. This radius is also 5, which means my total length of this side of my triangle is 15, right? So I now have a right triangle where I have x squared plus 15 squared is equal to 20 squared. I'm going to go down so we can figure that out. So I have x squared plus 15 squared is equal to 20 squared. X squared plus 225 is equal to 400. Subtract the 225 from both sides. X squared is equal to 275. Take the square root of both sides. X is equal to radical 275, which I can pull out a 25, and that leaves me 5 radical 275. Sitting for 8 must be 11. 5 root 11. Whoops. Whoops, I know I did something wrong. Sorry. This is 175. I was just checking my math. Think about it. That's not what I thought I was supposed to get. So this is radical 175, which is actually 5 radical 7 when you pull out the 25. All right?